Hello friends, and this is the second part of heart disease model building process. And in the first video we have seen how to import basic libraries, reading the CSV file with the help of pandas, and loading the data set, seeing and checking the data, exploring the data for useful information, determining the shape, description, seeing if there is any null value, data type, and seeing that all are integer format, so we don't have to do any data pre-processing or cleaning of the data. And then we find the correlation of the attributes by heat map, by scatter plot, by histograms, seeing the shape of the data, box plot for outliers, and then we've seen the categorical plots, and we've seen bar plots for various variables, count plots. We've seen so many count plots when we've plotted them with various and analyzing the data too. Then we've seen something very interesting here called the cross tables, and this is how we stack the data and see the visualization of it. And now coming to the second part of it with the preparation for the data to be given as an input to the algorithm. So what I do is, firstly I have to scale the data. Now what does the scaling means? See, I will not go into the detail, but just to tell you that it just scales all my data down either in some range between -1 to 1 or 0 to 1, so that all the values are treated equally and there's no discrimination, and it is easier for the algorithm to learn. So for further details for scaling standardization, please refer to the video, and I'll be providing it at the end of this video. So please do see that because it is important part. And now we come to this, what do I take? So I from sklearn model selection, I import train test split. sklearn has this feature of all the algorithms, classifiers it has got standard scalars there, so you know the packages. And since sklearn is an open source library, so these packages keep on changing, so just be updated with this, and by googling it you'll understand. So sklearn.preprocessing, you will get standard scalar. I create an object for that. Then what are the columns to scale? So how do you know which columns to scale? So you see here, compare these two data. I have the first data which has been something like this, and I see this age like this, and this is the resting, you know, blood pressure and thalage, and see the old peak. It is something which my algorithm would not understand. So what I do is I scale these columns. I scale all these columns. So what happens is, and when I fit it, when I fit these columns to scale, fit.transform with the function this, you see how it has been changed. The age has been changed, right? This resting blood pressure has been changed, cholesterol has been changed, and this old peak and thalage has also been converted into machine learning format so that algorithm understands it better. Now I come to seeing the shape of it. What I do is I drop the column. Now for train and test split, I have to have X training and Y train. So I have to have like X and Y data. And in X, I will not have the target because I have to train it, and this algorithm will be trained and it will be predicting the output and how correctly it will predict. So for Y, I will have only the target, and in X, I have all the remaining features. This is how I do it. And then I will give my size of the data: X train, X test, Y train, and Y test. This is what the object will be, and this is the sequence you have to follow. Then train test split X and Y, you split X and Y, and test size I give 0.3, and the random state is 40. You can give any random state. So when I run this, this will be divided, so you have to check it. So you print, okay, and when you print the size of all these data, all these, you will see that the X train is being divided as 2756, and you see that the training data is like 70% and testing data is like 30%, okay. or you can say, I can say that 0.3, like 0.33%, and remaining is the testing data. So what if I change the test size? So I have created a different notebook to show you this. And suppose I take this size as 2.0.23 and random state as same, like 30. So what happens to the size? The size changes. This increases the training size, and this is 3146 and test is 793. So you can just see the splitting part of it. If you just change this to 20 and then you print it again, see, minute changes. So now we come back and we first build the model. See, I have done fitted on various models. I have used 6, but in this video I will explaining only one, because rest follows the same logic. So you can just get the code on GitHub and understand it by yourself. And I'll just explain you the logistic regression, the first one. So what I do is I from sklearn again, and in linear model I have this logistic regression, and I create an object for that logistic regression. Okay, the same name has to be written here. So this is the one which will be fitted. Okay, so now in model 1 object I will fit this logistic regression, and it is X train or Y train and Y train, and I will predict this on X test. What is the prediction it is making on my X test, which is 1186. Okay, so now what I do is, now I have to check the accuracy. So what I do is I would predict it on my Y test. So from sklearn metrics, so from metrics I will import this confusion matrix, and I will print this confusion matrix, and this gives me something like this: 36, 4 and 3 and 48. We have covered confusion matrix and I've covered in depth, explained it many times, so please go and see this confusion matrix videos and also previous videos on machine learning project. So we just see that this is true positive. So 36 cases have been predicted rightly by my algorithm, and 4 cases predicted wrongly rejected, and 48 are false negative. All right, so true negative I mean, and this is false negative. So these algorithms, so recall and everything I will show you how does it look. Okay, so what I do is, now I will go through the accuracy, and in accuracy first I will test the accuracy of this. So my accuracy is coming to be 92% when I give this accuracy, and accuracy is what? Total predictions divided by the total correct predictions divided by the entire predictions. So you can just add this up, 36 plus 48 divided by the entire thing, and you will get 92%, right? So from sklearn.metrics you import accuracy score, and on y-test you make this predictions. What is this prediction? This is the prediction here which we are making here. Okay, this one. So y-test and x-test, right? So now how much is it giving me? 92%. Similarly what we got here, right? So it's almost the same. Now what I do is I import from sklearn itself classification report, and what I do is I print this classification report, and this is on y-test and prediction 1. So let's see the accuracy for the heart diseases, having no heart diseases. The precision is 92%. That means 92 cases are being rightly predicted by my algorithm, and recall is 90. That is true. The cases which have been missed out, right? So the recall is low, 90, and F1 score is 91. That is the harmonic mean between decision and recall. And as you can see, the recall, why is it low? Because of this matrix. These are the missed out cases by the algorithm, right? These are the missed out cases by the algorithm. Okay, so now we have similarly for the heart diseases which have heart diseases, is recall is good, 0.94. That means it is missing out, but it is also telling you that yes, these have been rejected, these have been wrongly rejected. Okay, now there are different models like decision tree, which is giving me certain accuracy. Again, the classification report I have done. In the end I'll show you the entire thing for convenience. See, I printed the accuracy of k nearest neighbor logistic regression, decision tree classifier, random forest classifier, naive Bayes, and support vector classifier. So you can see the accuracy. So this logistic regression is giving me the highest accuracy of 92%. And next is followed by support vector machines. No, it's naive Bayes. This is not support vector machine. This is naive Bayes NB, and then decision tree, and you can see it's 90% and SVC is giving me 87%. So you can just compare here which algorithm is giving you best accuracy, and you can just go on further then tuning this logistic regression further for improving more accuracy of this model, right? So go ahead with the logistic regression and use ensemble algorithms, AdaBoost or different boosters, extra trees to boost these algorithms. Next, I want to tell you one more thing, that this entire code will be available on the GitHub link, and please go through it. It is very simple, and just one code, if you understand once, you'll be able to replicate it for different classifiers also. Logistic regression, do not misunderstand regression with something called classification. This logistic regression is regression because it uses the linearity of the linear regression equation, but it classifies because it just logs down your information between 0 and 1, and um, it can classify things better. So this is used for classification model. So it is giving me good accuracy, 9.2%. So I think it was a good, interesting machine learning project, and hope you liked this. And if you really like it, please encourage and please tell me which all machine learning projects you face problem, and we can just work upon that. I can work upon that and get back. Please comment it on in the description box, and any questions, please feel free to ask. And this is a good platform wherein we all can learn and improve. So let's just be a part of the family, bigger family, and just learn machine learning. Just understand it very nicely and do good things, right? Okay, and so that's all for this video, and stay tuned for more upcoming good projects. I will do my best to bring good projects, and you also please help me with giving me good ideas of doing certain data sets. So thank you.